Hello, it's Paul with Logix Magazine. We help you go from self-taught beginner to automation professional. And the way we're going to help you do that today is we're going to share our Logix workshop series with you. And the first workshop we're going to share with you is the RS Logix 5000 pneumatics routine. That's where we build a pneumatics routine from scratch. Let's go ahead and get started. First thing we want to do is add a bunch of rungs for our outputs. I'll show you a couple different ways to do this. Here I'm going to copy with Control C and then Control V. I will paste. We need about 13-14 rungs. The next thing we want to do is we want to address our outputs. And since we've addressed these sequentially, that makes the job that much easier. I've went ahead and sped this up. So the next thing we want to take a look at in our program is the first instruction on the first rung 0. So what do we need to consider for the very first rung? Well, let's go ahead and go into our projects tree and go to our main routine. And in our main routine, we have a lot of information, but we're only interested in the very beginning, where we get our power. So we have our power control input and a soft start enabled. We should begin here. The reason for that is that this soft start enabled controls all of the outputs. We will have control power to our processor and throughout our control panel, but without this input we will have no power to energize our outputs. So let's go back to our outputs routine and let's put in an instruction here. That is a status startup. Alright, let's find our tag, status.startup 0. Okay, that's the first one. Now, as we've identified that is an important instruction, it will determine our ability to energize our outputs. That is the instruction that we will need on all of our rungs. So we will copy that instruction and paste it to all of our rungs. Now I want to take this moment and share with you that the way that I'm building this routine is based solely on the fact that I am also trying to instruct you on how I would build this routine, this outputs routine. There are many ways to do it, and to be very efficient would be possibly done differently. But I want to go instruction by instruction, rung by rung, and explain the thought process that it goes into building your outputs routine. So let's get back to it. Now the next very important instruction, what would that be? Well, we need to understand our machine. Let's begin by considering that we have an auto and a manual cycle. So let's go ahead and put in our manual. And that I happen to know would be PV, PL. This is a status bit that lets me know if the manual extend bit has been energized. Let's go with 4, 0. Okay, what this is saying is, without adding any other instructions, assuming that this first rung is an auto rung, and we will build it to be so, that if it's put in manual, we can manually energize that bit, and another part of the program in the manual's routine, that it will energize, and then we'll be able to manually extend this clamp. All right, so this is our manual bit. This is our manual branch. Therefore, it would be safe to assume that we would have the exact same instruction in each of our rungs. Pay particular attention to the numbering scheme that is used. All items are, I've went ahead and sped up the process and programmed all of the manual instructions into our routine. Now, the next consideration is that we need to make sure that our left-hand nest is activated. We have made a decision to use the left-hand nest. All right, you'll notice that our instructions, as you recall, is that we have two nests, a left hand and a right hand. So let's go ahead and get our instruction for our left hand nest. And what we're going to be looking for is our status bit for the nest. We're going to have 0.2, and that's our left hand nest is active. Okay, now that we have our left-hand nest active, this is an auto rung, and this next section is very critical to understand, and that is that we want to only run our AutoCycle. Well, we want to run our AutoCycle in specific conditions. Okay, one of them is we only want to extend our clamps, which is clamping the part and holding the part, when it's given the instruction in the auto sequence. So if you have considered what your auto sequence is, let's go take a look at that. Want to make sure that we're in the sequence to close the clamps, all right? And that would be all of these rungs conditions have been met, and it's sequential. We're using a status sequence latching bit to manage our auto cycle. So once this auto is in progress, that has been when high, and then we are able to close our clamps. So we want to be very cognizant of our auto cycle conditions. So let's go back to our outputs. So we need, before we extend these, we need to make sure that we're in our status sequence is to close the clamps. And if we look back on our auto instruction, closing the clamps is right here. This is the instruction that we need to make sure that that status has been met, that it's high, before we permit this output to be energized. So let's go to status.sequence, and we'll go 0.1 and close the clamps. Now, it needs not to have been given the instruction to open the part clamps. So we have a condition so that we have a closed clamps, but do not have an instruction to open the clamps. So it's between, it will stay closed until the sequence to open the clamps has one high. And we'll take a look at what that means. If we go back to our auto routine, so we have our closed clamps. The next sequence we need to consider is, when does it tell it to open the clamps? when we're all the way through all of this sequencing down here at rung 19, it says open the part clamps. All right, so we want that to be energized all the way through all of these instructions, all the way down to this routine here, where in the sequence we have completed the AutoCycle and we are now telling the clamps to open. When that happens, we want to release this clamp, okay, and permit it to open. So we need to go to 23. Okay, so it needs to close when we are at that part of the sequence to close, and then open when we are at this part of the sequence to open. This auto routine, this auto rung here is based solely on the auto routine. Okay, and now when we look at it, we have our manual instruction down here. So now we have our auto and our manual, but are we still missing something? And I would say indeed we are. What we're looking for next is something I normally want to consider first is safety. So when we are cycling our machine, rather in auto or in manual, there are a couple of things we need to consider. In this case, we have a light curtain, which is our primary safety feature beyond the e-stop. And that would be something we need to consider. In the manual cycle, if we're manually cycling the machine, this clamp, would we want to permit the light curtain to be broken? No. What about in an auto cycle? No. But that by itself isn't always enough. So let's go to our main routine. And in our main routine, we have a rung that's called everything's A-OK or all okay to run. Let's find that routine. And that routine carries a lot of weight throughout our cycle. Okay, obviously for everything to be okay to run, we need to have chosen one of the nests, and by default, up above on one of the other routines, or the other rungs, we automatically, on the first scan, we choose both. You have to manually choose one of the other ones in order to not have both of them. So again, by default, we are choosing both on left and right hand nest. One of them must be chosen for everything to be okay to run. We have an auto mode. Okay, now this could also be referred to as everything okay to run in auto. Okay, we have our control power, which means we have power to our outputs. We have the light curtain, that's okay. We have our soft start enabled, and we have our machine is home. All of the cylinders are in a home position. They are not extended or retracted. Well, depending on the application, it may need to be extended versus retracted. But in this case, all cylinders are retracted as they are supposed to be. Okay, so what we need to look here is a lot of these conditions. We go to put it in manual mode, if I pulled off of this, all of these conditions, I wouldn't be able to manually move it because it would need to be in auto. All right, the light curtain is okay, meaning it's not broken. Okay, so these are some of the considerations you need to consider. If all of the cylinders are not home, and the way we would know that is we would have our inputs indicating that they're all home, then we wouldn't be able to manually move them at all, even in the retract. So if they're not home, so we cannot use this, and we need to consider exactly what we need to add to our output rung to consider safety. So an item to consider is the light curtain. Okay, we don't want the light curtain to be broken. All right, we don't want it to anybody within the light curtain or within the safe space the machine, whether it's in manual or in auto, and that's an irrevocable fact. All right, for manual and auto, and that's something we definitely want to consider when we're writing our program. Parts missing. All right. Parts missing. We got 1.1. And there we go. So that's a condition we want to have. Now, when you think of all the other conditions, those that I outlined, light curtain is very important. We have our soft start, so we have our power to energize our outputs. We have a irrevocable safety condition, whether it's an auto or manual. We have our left nest has been chosen. That's important because it's a left part clamp. We are in this top rung, we're dealing with our AutoCycle, so between 0.1 and 0.23, we want this fully energized in the auto routine, and or we drop down here and we can manually energize it. There is the thought process for this first rung. Now I'd like to walk through the second rung. And then what we will find is all the subsequent rungs will essentially be the same of these two rungs, because all the rest of them have an extend and a retract. As we have here, left-hand part clamps extend, left-hand part clamp retract. And we have the exact same thing for every cylinder as we move through. What I wanted to share with you primarily today is the thought process behind writing this routine. So let's go ahead and get started. So now obviously we're back to our light curtain condition. Okay, that must be there. Now, to retract it, right? To retract is a different thought process to a degree than extend. And that is, we have our manual mode here, right? But we also need to say, hey, in the auto mode, you need to be in the auto mode to be able to retract this. And we'll talk more about that in a minute. All right. Okay, so now, in the auto mode, we want to say, okay, the next process really is thinking about what is the condition that will require us to retract the clamp, okay? So one, it needs not be energized, extended, right? So we want to put that in here, right? And we want to say, hey, if it's extended, do not retract. Now, for it not to be extended, we need to not be in either of these two conditions here, okay? Very important. In the auto cycle. In the manual here, this will only energize this is a momentary button. This will only energize as I am pushing the button. When I let go of it, it will then de-energize this output. Now here, I want to make sure this is de-energized before I go to retract. If it's in auto, in between these two, and I go to manually retract it, I'll have the cylinder fighting itself. I hope that makes sense. All right, the next thing to consider is under what circumstance will we need to retract this clamp, right? And that's to home it. We need to bring the cylinders back to a home position. We've made that condition a requirement in our project, right? So we're going to put this right here. So if it's in auto mode and it's not fully back and the left-hand clamps are not extended, then we'll go ahead and retract. So, and we'll talk about the homing instruction here in just a minute. Let's go ahead and get this in here, and then we'll take a look at the routine, the homing routine, and take a look at what we're talking about. So in the homing routine, what we have is right here, homing reset active. In auto mode, so if it goes to auto mode and the machine is not home, it will retract the cylinders. As soon as we gain control power, it will retract the cylinders. If there's a reset, it will retract the cylinders. And this branch down here is just to hold it until these conditions change. Okay? As soon as we go, as soon as one of these conditions change, then this will drop out. All right? So let's go back to our outputs routine. And our outputs routine, we're saying if it's not homing, go ahead and retract it. All right? I hope that makes sense. So let's review these two rungs, because essentially the rungs following this are virtually identical. Okay, so as soon as we get our control power, we have that soft start enabled, that goes high. The light curtain's not blocked, then this will remain true. The PLC nest, as soon as that left-hand nest is active, and if you recall, on the first scan, both the left and right-hand nests go true. We get a command between the sequence here, the command to close the clamps, but it has not reached sequence 0.23. Go ahead and extend it. Or, as we come down here, if we get a manual instruction, a momentary push button that tells the clamps to extend, then it will extend. Now, in order to retract that cylinder, we would have, again, the soft starts, we have our control power, the light curtain is not blocked, it's in auto mode. The condition for homing and reset is not active. So that means those conditions we talked about in auto mode, first scan, reset, all those conditions are met, then this is going to pull those cylinders back, right? That'll say go ahead and retract these cylinders if these conditions are not met. The left-hand parts are not extended, so these two need not be the same. Then go ahead and retract the cylinders, or go ahead and retract the cylinders if it's a manual instruction. Okay, if it's a manual instruction to go ahead and retract the cylinders. If this is your first time here, go ahead and subscribe, comment, and share. And don't forget to hit that bell so you'll be notified each and every time we produce a video. So until next time, my friends, keep programming.